I welcome you all to today's video tutorial, today's lesson, where we are going to be revising on vectors. Like we've been doing in our previous videos, we've been solving mathematical papers topic by topic. We solve at least 3 papers in one video tutorial. And so for today we are going to be solving vectors in the 2016 papers, 2017 papers, and 2018 papers. So let's quickly go ahead and begin solving our first question, and we are going to start with 2016. So we're going to look at the 2016 internal paper. And the question that came in the 2016 internal paper 2 for vectors is, and I read, in the diagram below, OAB is a triangle in which vector OA is equal to 3 and vector OB is equal to 6B. OC to CA is equal to the ratio 2 to 3. And AD to DB is equal to the ratio 1 to 2. OD meets CB at E. And there is our diagram there which we are looking at. What we are from reading, they've literally just explained what that diagram is representing. We have our OA. We have our OA being equal to 3 there. We have our OB being equal to 6. Awesome. Question number 1. It says, express each of the following in terms of A and OB. Express each of the following in terms of A and OB. So now we are looking at the first question being finding vector AB. Finding vector AB. Alright. Vector AB there. To get vector AB, one thing that we must bear in mind first and foremost is that vectors are about direction. So therefore we need to follow closely the direction of these arrows which are being indicated even in our diagram. And also if we look at our first question, which is asking us to find vector AB, the arrow is pointing starting at A ending at B in that direction, which means that you have to start from A and you have to end at B. So we're going to start from A. So whichever route we decide to get to use, we should still end at B and start from A. So though there may be many routes to reach B, there is only one route which we can use. And in this case, the route we are going to use, we cannot use A to C then C to B because we don't know the value of that and we don't know the value of that alone. So we have the value of A to O and O to B. Therefore that qualifies, and we say we're going to use vector AO plus OB in that way, which is going to be equal to, what's our value of vector AO? It's 3. It's 3A. Is it just 3A? No. In this particular case, we're looking at AO, and 3A was the value of starting from O going to A. Now when we say AO, we are moving from A going to O, opposing the direction of that arrow. Therefore, our value there becomes a negative. So we have 3A plus our OB being 6B. 6B is maintained positive 6B because we've followed the direction of the arrow. Therefore, our answer, well, this is okay the way it is, but it's more preferred to make your vector be positive, so it becomes 6b minus 3a. There are no calculations which have been done there. We just swapped this, we've made it to be first, and then that it has followed in that way. Is that our answer? Yes, that's okay. However, we can still factorize so that, it looks better, We just factorize, we reach the very end. So what's common there? We notice that 3 is common. So 6 take away, 3 into 6, it gives us 2b, minus 3 into 3a, it gives us a. And we can end there in that way. So that is our first answer. That is our first answer. Question number 2 says we are supposed to express in terms of A and or B vector OD. OD. Vector OD is what we are trying to find now. Vector OD. So what is OD? O to D is there. That's our O to D right over there. So which route do we choose to use for us to be able to find vector OD? Vector OD. Which route do we use to find? So for OD, we are starting from O ending at D. We can either say O to A, then A to D, or we can say O to B, then B to D. Do we have anything that is going to help us to find OD? Yes, we have the value of O to A, we have the value of O to B, but we have the value of A to D and the value of B to D. Yes, we do have. We don't have in the question, but if we follow the ratios that we have been given, we are able to find the very answer that we are looking for. When we go back to the question, there is a very interesting ratio that we were given. In the question, we were told that AD to DB is equal to the ratio 1 to 2. AD to DB is equal to the ratio 1 to 2. This means that A to D is 1, then D to B is 2. So, if we are to say in our question that maybe we are going to use, in our question, we decide to say we are going to use, we'll go OA plus AD. Let's say this is the route which we decide to use. Okay, that's the route we've decided to use, for instance. What that will mean is, quite alright, we have OA. We know that that's 3A. But what about AD? So that's AD. So how do we find the value of AD? According to the vector, we know that AD must be equal to, we have 1 there. That's how we interpret ratios, 1 over the total line. If you add 1 plus 2, you get 3. So we have our 3 there. But it should be 1 over 3 of what? 1 over 3 of the total line AB. So it should be 1 over 3 of AB. And what is that? 1 over 3 of AB is literally this. So 1 over 3, then you put a value of vector AB, which we just found in there. So which is going to be equal to, maybe let's pick the value of AB from there. You say 6B minus 3A. in that way. So that's the value of AD. So even as when we come now to finish our calculations there, so we say AD is 1/3 open bracket 6b minus 3a close brackets in that way, which is going to be equal to 3a plus 1/3 times 6b is equal to 2b minus 1/3 times 3a is equal to a. Having done that, let's group the like terms. That would be 3a minus a plus 2b, which is going to be equal to 2a plus 2b, which is equal to, let's now factorize. So we can now factorize the last part. We're going to say 2 open bracket 2 into 2a, it gives us a, plus 2 into 2b, it gives us b. And that becomes our answer. That becomes our answer. So quickly, let's do our third part, which is our C. Let's do our third part, which is our C. Let's solve our C here. C says, find vector BC. We're now looking for vector BC. We are trying to express BC in terms of A and OB. So where is BC on our diagram? So when we look at our diagram there, we're able to see BC. Oh, pardon me. Okay, so BC is that route there. From there all the way to there, that's BC. That's BC. That is our BC. So for us to be able to get BC, there are quite a number of routes. We can use B, A, then A, C, or we can use B, O, O, C, or we can use B, D. We go with vector B, O, then O to C. Right, so having that, we know what our BO is, that's 6, but since we are opposing the arrow, it becomes -6. -6b plus, what is our OC? Our OC. Now, for us to be able to get our OC, we go back to the main question. We go back to the main question. In the main question, we were told that OC were given a ratio, and the ratio said OC to CA, OC to CA is equal to the ratio 2 to 3. Is equal to the ratio 2 to 3. Which means that if we are looking for OC alone, maybe let me show you on the diagram. So if we look at the diagram that we have here, we are looking at OC, which is OC to CA. So meaning there we have a 2 and there we have a 3. So if you add the total of this line 2 plus 3, it should be able to give us 5. So meaning for OC alone, it should be 2/5. 2/5, which line are they sharing? They are sharing line OA. So that is what is going to help us to find the value of OC, vector OC rather. So 2/5 open bracket, what is the value of OA? The value of OA, the value of OA, we know that it is 3A. So that's what we are working with. That is what we are working with. So we're going to write our value of OC being that one, 2 over 5 open bracket 3a. It is equal to that plus 2 over 5 times 3a, it's giving us 6 over 5a. So that is all. This answer is fine. You can end there. However, it's always more preferred to leave your vector positive. So just bring the positive in front. 6 over 5a minus 6b. And that becomes your answer. That becomes your answer. If you did that, then you got it correct. And finally, let's do the last part of our question. Finally, we are solving the last part of our question, part 2. Since whatever we are doing was part A, now let's do our part 2. Just over there. Our part 2 says that given that vector BE is equal to HBC, express BE in terms of H, A, and B. Express BE, express vector BE in terms of H, A, and B. What do we do for us to be able to express that in the right way? So now we've been told the value, okay? We've been told we are trying to express BE in terms of H, A, and B. So what do? We carry it from there. We just say H open bracket. We know the value of BC. How do we know the value of BC? Well, from calculating it in our question C there. So we just put in brackets the value of BC, 6 minus 6b, close bracket. What do? Multiply H with everything that is in there. So H times 6 over 5, it is going to give us 6H over 5A minus H times 6B to give us 6HB in that way. Once we do that, we can now summarize. So that answer is okay like that. You can end it there. However, you can still factorize because 6 is common. So you can finish it as 6. So 6 into... So if we're trying... We can factor out 6. So remove 6 from that. You get... Let's say open bracket H over 5A minus, remove 6 from there, you get HB, and that becomes our answer. That marks the end of the 2016 internal paper for vectors. Let's move on to the 2016 GCE vector questions. GCE paper 2 vector question. It came as question 6A, and I'll read the question ahead of you. In the diagram below, vector OA is equal to A and vector OB is equal to B. C on AB is such that AC to CB is equal to the ratio 2:1, and B on OD is such that OB to OD is equal to the ratio 2:1. Questions. Express as simply as possible in terms of A and slash OB. 1 vector AB, 2 vector AD, 3 vector CD. Let's quickly go to our solutions. So now when finding our solutions, maybe before we begin this one, let's just take note of the ratios that we've been given. We've been told that AC to CB is equal to 2 to 1. And we've also been told that OB to OD is equal to the ratio 1 to 2. So now we are finding the first one. We are saying find vector AB. The first one, we're trying to find vector AB. That's what we've been asked to find. And so AB, we know O to A is equal to A there, then O to B is equal to, O to B being there is equal to B. So meaning for us to be able to get that, we start A is in front and to B, meaning we are starting at A. We can't use A to D then D to B because we don't know the values here. Values have not been given. So we take the root which has values which have been made available. So A to O plus O to B. Plus O to B in that way, which is going to be equal to A to O is A. How is negative A? Why is it becoming negative A? Because we are opposing the arrow. Plus OB. OB. So we've been told that OB is equal to B. So this can be our answer, but like I was saying in the 2016 internal paper, it's more preferred to leave the vector as a positive. And the only thing that it takes to leave it as a positive, get the positive letter there, put it in front and get the other one and put it the other side so that you leave it as a positive in that manner. Let's go to our second question. Our second question says find AD. AD is what we are looking for. Where is AD? A to D. A to D is what we are trying to find now. So A to D is quite interesting because first and foremost, you know that the root which we will take will be A to O plus O to D in that direction. So our root is going to be A to O, then O to D. However, we know that OB is equal to B. We know that OB is equal to B. What is BD then? What is BD? Because we need to know the value of BD so that we can add to have OD. However, if we check, we go back to the top question, we have been told that OB to OD is running with the ratio 1 to 2. So, these two ratios, if you look at these two ratios carefully, they are two different ratios. So, even in the way that we are going to interpret them, it is going to be different. For instance, let's try to interpret AC to CB. AC to CB. So this one starts with A to C, then you continue from C being common to D. So this one will mean 2 to 1. That is what this ratio will mean. So this one will mean this one will be 2. This one is going to be 1. But if we come to this one, we are looking at O to D being 1. But again you say O to D being 2, literally the whole lot of it from here to here. We are saying it is what? It is 2. Now, what does this mean or imply to us? What it means is that if O to B is 1, it means that B to D is also 1. So that if you add 1 plus 1, it should be equal to 2. That's what it means. Or if you wanted to express this ratio the way this one was done, would have something like OB to BD, it would be to the ratio 1 to 1. That is what this means. That's how we interpret that. So now, if that is how we interpret it, what then? Maybe let's go ahead and begin to calculate now. Now that we understand that, so AD is equal to OA. What's our OA? Our OA is, wait a minute, we're going A to D, so we're starting from A to O. So A to O is going to be negative A. You already understand why it's negative A, plus O to D. So O to D, if O to B is B, so meaning that one is also going to be B. So B plus B, it should be able to give us 2B. Then we leave it as a positive vector. It's going to be 2B minus A. And that is our answer there. That is our answer right there. Let's go to our third question. Our third question is asking us to find CD. Our third question is asking us to find CD. So CD is C to D. C to D. That is what we are looking for. That is what we are trying to find. For us to be able to find CD, there are quite a number of routes we can use. We can either use C to A, then A to O to D, or we can go C to A to D, or we can go C to B, B to D. And for me, this one looks shorter. What about the values? I think the values there, we can be able to find them also. So we can run with C to B plus B to D, which is going to be equal to, what's the value of CB? CB, what's the value of CB there? CB, we have something in that ratio, we have CB there. So they've told us that CB is 1. AC to CB is equal to the ratio 2 to 1. So what this means is if we're going to find CB alone, it's going to be equal to 1 over 3. Where 1 over 3, that's 1, that's 2. So if you add 1 plus 2, that's the total 3. So that's 1 over 3, that's the ratio. 1 over 3 of what? 1 over 3 of the line AB. That's what we are going to have. That is going to be our CB. So our CB, we've been told it's 1 over 3 of the line AB. So what's the value of AB is what we are from finding there. So we just replace that. Our AB is B minus A, open bracket, plus what's our BD? What's our BD? Our BD in our previous question, we are from sorting it out. We said that OB to BD is equal to the ratio 1 to 1. So if that is B, it means that that is also B. So our BD is B. This is going to give us 1 over 3 times B, 1 over 3 B, minus 1 over 3 times A. It's going to give us 1 over 3 A plus B. Let's group the like terms. 1 over 3b plus b minus 1 over 3a. Let's do our calculations. Quickly, you can do common denominator there. You can do that over 1, so that's going to be 3 as a common denominator. 3 into 3, 1 times 1b, you get b. Plus 1 into 3 times b, it gives us 3b. Minus 1 over 3a. So that is going to be equal to 4 over 3b minus 1 over 3a. Minus 1 over 3a. That is what we are going to get as our answer. So you can either end it there, or you can take it further and factor out what's common, which is going to be 1 over 3 is common. So it can give. That marks the end of our solution. That marks the end of our solution for the GCE 2016. That's what was expected of us. Paper 2, vectors, internal paper. The question reads, in the diagram below, vector OP is equal to 2P. Vector OQ is equal to 4Q. And vector PX to XQ is equal to 1 to 2. That's the diagram that we have, that is you are seeing there. Question 1, express in terms of P and stroke OQ, A, vector PQ, B, vector PX, C, vector OX. And the second part of the question says, given that OC, vector OC is equal to H, vector OX, show that vector CQ is equal to 4, open bracket, 1 minus H over 3, close brackets, Q minus 4H over 3P. Let's quickly begin to solve that. So, part 1a says, find vector PQ. Find vector PQ. Where is PQ? PQ is that one. So quickly, to find PQ, we know that we cannot use that root because it has no values, but that root has values which can help us. So we therefore take P to O plus O to Q plus O to Q. That is going to be equal to P to O is negative 2P. By now you know why it's a negative, because it's opposing the direction of the arrow, plus OQ. So O to Q is going to be positive 4Q. Well, it's flowing in the direction of the arrow. So that one, it is mostly advised, just make it a positive vector in that way. Get this, put it this side, and this one let it remain 2P in that way. Then you can factorize that now. 2 into 4, you have 2Q there, minus P in that way. We've solved B. Let's quickly go to B. We've solved A. So that's a solution for A. Let's quickly go to B. B is asking us to find vector PX. Vector PX. Now, when dealing with vector PX, some of the things that we've been told in the question is that PX2 to XQ is equal to the vector 1, 2, 2. So Px to Xq is equal to the ratio 1 to 2. What this means is that is our 1 and that is our 2. So the total division for the line, this one is 3. 1 plus that is equal to 3. So it means that if we want to get px alone, it's going to be equal to 1 over 3. This 3 is 1 plus 2. That's the 3 times the total line PQ. Times the total line PQ. That's what we have there. Now, if that's it, then our px is going to be equal to 1 over 3, open brackets. Our PQ is what we are from finding, but we pick it from there. So we say 4Q minus 2P. That's our PX. So literally we can pick it from there. PX is equal to PQ, which is going to be equal to 1 over 3, open bracket, 4Q minus 2P, which is going to be equal to this times that to give you 4Q over 3 minus 2 over 3P in that way. 2 over 3P in that way. So that becomes our answer for B. Let's quickly go and solve C. Part C of this question is asking us now to find vector OX. So to find vector OX there, we look at the roots that we have. We are considering vector OX. So to get vector OX, we can use O to Q, or then Q to O. That's one way. Or we can use vector OP, then P to X in that way. So for me, I prefer using vector O to P, then P to X. Why this route? Because at least we know what Px is. This other route will require for us to start finding a Qx. So with that, we know that our OP is equal to 2P plus our Px is equal to 4 over 3Q minus 2 over 3P. Having done this, let's group the like terms. So at this level, we group the like terms. We know the 2P there, and we bring this one minus 2 over 3P plus 4 over 3Q in that way. So let's do our calculation. We can try to do the fractions there. So let's solve this first. Let's add, then we have that in the end. So common denominator there, 3. 1 into 3, 3. 3 times 2P. It gives us 6P minus 3 into 3, 1. 1 times 2, 2P plus 4 over 3Q in that way, which is going to be equal to 6P minus 2P is going to give us 4P over 3 plus 4 over 3Q in that way. Oh, this is also 4 over 3P in short. This is also 4 over 3P. If you do that, that becomes our answer. That becomes our answer. One of the things that we can also do for that is that we can factor out what is common. What we notice is that 4 over 3 is common, so we can do that so that we have P plus Q. And that remains as our answer. (2018) Paper 2 Vector Questions. The vector question came as question number 6A in 2018 internal, and the question reads: in the quadrilateral ABCD below, vector AB is equal to A, vector AD is equal to B, vector BC is equal to 2B, and AE and vector AE to AC is equal to the ratio 1:3. Question: find in terms of A and slash or B, A, vector AE, vector AE. So where is vector AE? Vector AE is here. AE, AC, AB, or pardon me, AD and AB there. Then we have BC there. So where is AE? AE is there. How do we find AE? So now AE is equal to the ratio that we have has told us that A to AE to AC is equal to the ratio 1:3. So now AC is from this point all the way to that point. That is 3. It's considered to be 3. However, so that's the 3 that we are seeing is from A to C there. The entire thing, the entire line, that's a 3. Then AE, out of this line, just A to E, it's a 1. So this means that AE alone must be 1/3 because the total line we've been told that it is 3. 1/3 of what? Of the line AC, which will be equal to 1/3 1/3 open bracket AC. So what is AC? What is AC? Now, for us to be able to find AC, we need to calculate. We've not been given AC already. However, we can calculate AC. We can calculate AC using AB plus BC, which will be equal to AB is A plus BC, which is B. So that is AC there. So we put, okay, so pardon me there, our BC is 2B. Our BC is 2B, so there we have 2B in that way. 2B in that way. So now we are going to put A plus 2B. So that becomes our answer. Let's go to our question. Our second question, question B. We've been asked to find vector BE. Find vector BE. Let me change the color of the pen. Find vector BE. Where is BE? B to E. It's there. B to E is there. What formula do we use for us to be able to find BE? We can say we're starting from B and ending at E. So BE is there starting from B and ending at E. We can use B to C, of which we have 2B, but C to E we don't know the value. Therefore we can use what we already know, B to A, then A to E. So we can say B to A plus A to E, which will be equal to, what is BA? BA is negative, A there, opposing the direction of the arrow, plus AE. AE is literally what we are from finding there, which is plus 1/3 open bracket A plus 2B. So we can calculate that one quickly. plus 1 over 3 times A is 1 over 3A plus 1 over 3 times 2B, it gives us 2 over 3B. 2 over 3B in that way, which is equal to, now we have something to calculate. We have something to calculate there. Like terms have already been grouped, so we can say over 1, common denominator 3, 1 into 3, 3 times A gives us negative 3A, plus 3 into 3, 1 times 1, it's A, plus 2 over 3B. When we add that, it's negative 2 over 3A plus 2 over 3B. Is that our answer? Almost. Let's put this as a positive vector, which is going to be 2 over 3B minus 2 over 3A. Having found that, let us now put this, let's factor out what is common. So we know that 2 over 3 is common, open bracket, B minus A. And that becomes our answer. That becomes our answer. That becomes our answer. Let's work out now our C. Our C says find BD. Find BD. So BD is going to, where is BD first? We are looking at BD. B all the way to D there. So BD, we are going to take which root? The known root, which is this one. We are going to say BA plus AD, which is going to be equal to, what's our BA? Our BA is negative A plus our B there. So BD is literally equal to B minus A. That's our value. Part 2. We've answered the first part of the question. Now let's go to the second part of our question. The second part of our question says, hence or otherwise show that B, E, D are collinear. Show that BED, points BED are collinear. So how do we do that? How do we do that? So first and foremost, the few things that you are supposed to know about collinear, what I mean is show that the points B, E, and D are on the same line. Show that the points B, E, and D are on the same line. That is what we are supposed to show. Now, when showing that they are on the same line, or they lie on the same line, they lie on the straight line, we are not supposed to use crook method or guesswork, but rather we are supposed to show mathematically. So how do we show mathematically? So what we are going to do is we are going to begin to let them know that, okay, we're going to tell them that since vector BE since vector BE, which is BE, is equal to 2 over 3, open bracket, B minus A, BD, vector BD is equal to B minus A. So if you look at this, and you also look at that, what it's able to show us, or what it is able to tell us, is that BE is equal to 2/3 BD. That is what we are able to learn. It's able to tell us that BE is equal to 2/3 BD. So that if we have BD and we multiply it by 2/3 of BD, it should be able to give us the actual answer of BE in that way. Having done, or rather shown like this, we can therefore say the points B, E, and D are collinear. That marks the end of our solution for 2018 paper 2 internal vectors.